So there will be times when you're dealing with a key guard that's going into a hard-sided case, or it may be a soft-sided case, but it has an insert that's hard-sided, and its purpose is to protect the screen with a screensaver. In many cases, those cases, no pun intended, have a very narrow opening that just barely surrounds the real estate of the screen. And if you were to just use keyguard.scat as it's been designed up to this point, and you measured the height and width of the case properly, of the opening in the case, you would stumble across something like this. So what I have here is a keyguard designed for an iPad Air, and the measurements that are taken on it's in portrait mode, but the measurements that are taken on the case are that it has a height of the opening in the case of 201 millimeters and a width of 150 millimeters. So that's what we have over here. And we'll see what happens as soon as we have a case pull down to yes. So we see that we've trimmed off everything that is outside of the opening in the case. And it's cut this key guard very tightly, very close to the edge of the grid area and the edge of the message bar up above. In fact, we can zoom in on this and see that this edge here is about 1 millimeter wide. These down here are probably 2 to 3 millimeters at the base wide, but up here certainly this is going to be a weak spot in the key guard, and just through some accidental rough handling we could easily break off this top part of the key guard. So what do you do when you have a case like this that has such a tight-fitting opening? Well, there have been two new options added to the tablet case section of options. One is a height compensation for tight cases, and the other is a width compensation for tight cases. And what it's going to do, we'll see this in a moment, is it just adds additional thickness to the sides or top and bottom, because this is a portrait mode case, so this is the top and this is the bottom. These are the two sides. And we definitely need to add some more thickness to the sides. What we pick here is going to be distributed evenly among the two sides. So if I put 4 millimeters of additional width, it'll put it's going to add 2 millimeters of width here and 2 millimeters of width here. It's not 2 additional, just a straight 2. It's going to make this 2 wide and that 2 wide instead of the current 1 wide, 1 millimeter wide. So let's just give that a try. Let's add something to the width. Take it up to 4 millimeters, and you can see now that this is much thicker. You could run into the same issue if the case fit more tightly along this dimension, in which case you can similarly add more thickness there. You see it easily here. You don't see it quite as easily on the bottom, but it does occur there as well. And maybe the thing to notice, let me bring these back. The thing to notice is that the grid itself doesn't change size. These rails stay in exactly the place they were to start with, so they will always be aligned with the center between tiles. It's only these outer edges that get thicker. Well, that thickness has to go somewhere, and what it's going to do is it's going to encroach on the outer cells. And if you had anything displayed on the edges of this bar, it would encroach on those elements as well. But it's a way to get a thicker perimeter, and therefore a more robust, less fragile keyguard. So adding something around 2 millimeters on all sides, not a problem. It makes this cell, this cell, this cell, all the ones along the bottom, the ones on this side, a little bit thinner. It just encroaches on their space.